Good afternoon, everyone. My name is Kristen Foster. I am Vice Chair for the Transportation Infrastructure Research Council, and thank you for being here today. Welcome to today's webinar, which is sponsored by CTS. A little bit of background on the council. The CTS councils provide a forum for transportation professionals and researchers to exchange information on current issues and trends. They bring together university faculty and staff with practitioners from the public and private sectors to recommend direction and participate in improving the center's research, education, and engagement programs. Sam will share the link to the council's information in the chat shortly. Today's webinar features a presentation on keeping roads strong, mitigating pavement tenting and transverse cracks. We are looking forward to audience participation and questions during the Q&A time, which will follow the presentation. We encourage participants to use the Q&A at the bottom of your screen anytime to type questions or comments for the speakers. During Q&A, at the end, you could use the raise hand feature if you prefer, and then we can unmute you to share verbally. This event meets the continuing education requirements for 1.5 PDH credits and 1.5 AICP certification maintenance credits. If you need a PDH form, please send a chat message to all panelists with your name and email, and we will email you the form following today's event. CTS has hosted a variety of transportation research webinars this fall that you may be interested in. To see recordings of all previous webinars, visit the CTS website. CTS is hosting our annual research conference next week on November 6th. Upcoming webinars include asphalt art and aesthetics, research guidance, and community impacts on October 31st, and another webinar on innovations for energy efficient transportation on November 13th. Finally, if there are any students joining today, could you please send a chat with your name? We like to track the number of students who are engaging our events. Thank you, and next I would also like to share that Sam Han-Duville and James DeSoto from CTS are supporting today's event, and I'll give a brief description of the webinar. Transverse cracks in asphalt pavement are a common challenge in Minnesota, often leading to a secondary problem known as pavement tenting. This occurs when ice buildup causes pavement to lift near a crack, which can accelerate deterioration and contribute to potholes. This webinar will highlight a research project that aimed to identify effective strategies to mitigate pavement tenting. The project developed a best practices manual with guidelines and decision tools to help agencies select solutions based on pavement age, condition, traffic levels, and soil type. Presenters will discuss the research findings and how they can be applied to extend pavement life and improve roadway performance. I am pleased to welcome today's speakers, Manik Barman, Associate Professor of Civil Engineering at UMD and also a CTS scholar, Chad Koistra, who is the Research Project Coordinator in MnDOT's Office of Research and Innovation, and Matt Hemla, who is the Deputy Public Works Director of Engineering and Program Delivery for St. Louis County. And next, I will turn it over to Chad.
Thanks, Kristen. I am going to just give a quick overview of our MnDOT research program and the board that is funding this research. So my name is Chad Koistra. I'm a research project coordinator in MnDOT's Office of Research and Innovation. Our mission is to conduct and support research to transform our transportation system, creating a better future for all. MnDOT's research program focuses on a wide variety of research topics and is driven by MnDOT offices and districts. All of our research projects are guided by technical advisory panels. These are local practitioners and others with technical expertise and really help make sure our projects stay on track and answer questions that can help practitioners out in the field and decision makers as well. We have three main funding sources for our research projects. One is directly through our office, MnDOT's Office of Research and Innovation. We also have federal funding that supports our research. And then the third one I'm going to talk a little bit more about is the Local Road Research Board. This is very unique to Minnesota. The Local Road Research Board, as I will refer to it as LRRB, was established in 1959 through state legislation. LRB sponsors transportation research, essentially to meet the needs of cities and counties. So again, across a wide range of topics, but LRB research is really driven by local transportation practitioners from agencies across the state. They submit ideas to LRB, and then the board reviews ideas and selects projects to support with funding. And the research is usually conducted by researchers from MnDOT, universities, and consulting firms. And then after research is completed, there's a wide variety of pathways that can happen, but oftentimes it leads to additional research, phase 2 or phase 3, technology transfer, such as through our LRB's Research Implementation Committee. Pardon? Oh, okay. It could also lead to piloting and implementation. You can see more information at LRB's website down there, and I'll put a link in the chat with that too. This is just an example of, I won't go over this as Kristen covered it, and I'm sure next 2 speakers will as well, but this project started as a need statement submitted to LRB. And this is just the language from that need statement. So gave an overview of the issue, stated that research is needed to determine possible mitigation, and then stated the outcome of the research should summarize best practices for mitigation and correction methods. So this was the need statement that put in, and Professor Barman's team received the project. So just last slide here. So how you can engage, there's a couple of ways. You can sign up for project updates on our project website for this project. I will add a link in the chat right after I'm done speaking. So you'll get notifications anytime a report is published or a webinar recording or anything like that. We welcome everybody to submit research ideas via idea scale. You can follow that link there. Any idea will be considered and reviewed by our committees and boards. And then, as I mentioned, all of our projects have technical advisory panels guiding the projects. We benefit greatly from local transportation practitioners and decision makers and others who would like to join join a TAP. So you can follow that link there, find more information about about what TAPs do and how to be involved. And then some links there for our Office of Research and Innovation and LRB's website. We have hundreds of completed projects where you can find reports and other materials about those projects. Each website has a project database that I've linked there. So I'll throw some links in the chat and pass it along. Thank you.
Thank you, Chad. We'll turn it over to Matt now to start the presentation.
Hi, this is Matt Hempler with St. Louis County, Deputy Public Works Director for Engineering and Program Delivery. This project is kind of a big one for us in the sense that we're a really big county. We have about 3,000 miles of roadway, about half of which is paved, almost all bituminous. And so managing the cracks and what develops from the cracks is a huge part of our program. We spend a lot of our annual revenue, road and bridge revenue, on sealing cracks and fixing the damage that comes from this tenting and the cupping that ensues afterwards. And so anything that we can do like this study that we're doing here to give us a little edge on maybe preventing those or factors that go into exacerbating those cracks can be a huge leg up and save us actually quite a bit of money per year if we can start to get our arms around it. So we're pretty excited about what can come out of this, and hopefully we'll be able to put it into practice pretty fast. So looking forward to seeing this presentation, and we'll see how she goes.
Thank you, Matt. Monik, are you ready? Oh, you're muted.
Sorry. So I'm sharing my screen.
We got it.
All right, is it full screen now?
Yep.
Okay, thank you. Yep. So yeah, thank you very much for inviting me to speak on this particular topic, in which we have been working on for a couple of years, more than a couple of years. Yeah, myself, Manik Burman. I am a professor at UMD in the Civil and Environmental Engineering Department. I have two graduate students working in this project, and also Dr. Mihai Marasteniu from Twin Cities campus is a co-PI. So his group also worked a little bit in this project. As Matt and Chad already introduced themselves, so they are heavily involved in this project. I'm not repeating the title because we already discussed. So I would like to thank all the TAP members who have been, helping us, the research team, in this project, timely reviewing the task report or whatever suggestions we wanted from them. They have been very helpful. So I'll start with a little bit of introduction and background because we already heard some background about this project. I maybe will accelerate on these. We'll see a little bit of literature review on the objectives, research methodology, quantitative assessment of tenting, effectiveness of pavement treatments, and then frost heave of base layer, decision trees, and then some conclusions. I would like to mention that this is an ongoing project. This project ends on March next year. So we have some tasks we are still working on. So I just wanted to mention this one. So, yep, as we heard what is tenting, like the transverse crack, which comes in asphalt pavement in a colder region. So they kind of tented upwards because ice form bit below the asphalt layer or below the surface layer or at the interface between the surface and base layer, okay? Or also the ice can form with the base layer, which can heave and then creates a tenting, okay? So a little bit of science behind it. In pavement, if it is cracked, the water infiltration occurs either from rainwater, which goes in and then accumulates, and if it doesn't drain away, it can stay there. The snow melted water, the snow mixed with the de-icer that we use in Minnesota, that can go also based on the temperature gradient. So in the winter, the top of the pavement is colder, right? And the bottom of the pavement is warmer. So moisture generally flows towards the low temperature region. So in this case, so any water even below the subgrade can come into the base layer, okay? And then which can become ice, which can push the surface upward, okay? So this is a little bit of science behind the tenting development. Well, so and impact on the road performance, like all of us are familiar when we drive in the winter, we see that. So if we do not fix that, the crack, the age of the pavement, asphalt pavement, if they are tented, they can break easily. The crack becomes wider, and potholes can form, right? So now some literature. So this particular topic is not really widely researched. And I'm probably less than 10 research paper or article or report we got in this area. So you can find out like hundreds of research in other topic, but this topic is not that researched yet. So infiltrated water, poor drainage, of course, these are the concern, these are the cause, and it's a near surface phenomenon. Near surface means near pavement surface phenomenon. High fine contents increase the frost sensitivity, and the fines also, which goes into the pavement through the cracks, they can also contribute in denting. De-icing salt, they can also affect, because the de-icing salt, which if it goes through the crack, so the area by the crack, it will have more concentration of the salt, which will attract more moisture, which the process is known as osmosis, if you're familiar with that. So some more moisture will be present, and which can be ice. Freeze-thaw cycles, of course, will affect. That's why when you see, like in the early spring, when there is freeze-thaws, one day you see really cracks are very dented. If it is very cold, the other day, if the snow melts, then it goes down. And then the freeze-thaw if freeze-thaw cycles are more, then and if we have more moisture or the presence of snow is there, then tenting can even go more, because more water will come in. Uh, uh, our colleague Johnson, A.D. Johnson from MnDOT, and Roger Olson, a long time ago, like they have done a study, and then they found out that if the tenting height, if it is more than 2.5 millimeter, it affects the riding quality. A couple of more studies were done. One again in the MnDOT. So what they have done, they measure tenting. And then they also correlated tenting with international roughness index. Okay, so international roughness index, they correlated that. So international roughness index, this index actually, it kind of represents, or it's a measure of road roughness. The higher value is more rougher road. Okay, so as you can see, if on the vertical axis it's peak height below, or let's say it's tenting. So if more tenting, more IRI. So there is a very good correlation, okay, with an R square equal to 0.62. So the objective of the study is, I would first say, like, look, we try to understand tenting, how concerning it is, what kind of tenting amount. So in simple, I can say quantitative assessment of the tenting, how big, how high they can occur, and if there are any variables that they influence. So we did that study. And then we studied the effectiveness of different pavement treatments that are used in MnDOT or in Minnesota by other counties or cities. And then we studied the materials that goes into the base, aggregate base layer, which is susceptible to frosting. So we looked into that, and then we tried to see if we can change something in the base material which will decrease the frost heaving. Okay, and then based on these analyses, we tried to come up with some example decision trees. But this, as I said, we are still doing some task, and this is the task. We just recently submitted a report, so the report is being reviewed by the TAP. So all of the results that I'll show, this is really preliminary for this. I'll not go through a lot, but this task, this project had literature review, field work, some analytical study, laboratory test, and then eventually the best practice manual or the decision tree. That's our target. All right. So we will go through each one of those in this presentation later on. So let's talk about the quantitative assessment of tenting. So we went to the field to measure the tenting, and also we used some data that is available from other research, especially from the Minnesota DOT, which my colleague Ayub and John, they presented a paper in TRB. So I collected some data from that study too. So in order to measure the tenting, we really adopted a very simple method. very simple method you can see here. We made this tenting measuring, you can say, tool. So like 4 feet long. And then basically what we are doing is we are measuring 3 height, 1 height right in the middle of the crack or a crack edge, and 2 other measurement on the flat road. And then we find out what is the difference between the H3 and average of the H1 and H2. That will basically give us the tenting height. So, and then we took this measurement in 3 different locations for a single crack. And so with the help of St. Louis County, especially our project champion Matt and his colleagues, we got some sites to go and then measure the tenting. So these are like 6 different sections and their design. All right. So I'll just read like the last column. So you can see like we have very thin HMA layer, 3.5 inch to 7 inch HMA. Also the traffic varied from 3,650. Oh no, we have a 5,100 ADT as well. This is like annual average daily traffic. Okay. So also 531. So this is kind of varied, and also the design is varied. So so this is the result from one particular location. As you can see, like we had like 6 different cracks in here. The blue color is below color bar, the average, and the maximum. This was measured in winter, okay, in February. So you can see the crack number 5 was having like around 20 millimeter of tenting, pretty close to an inch here, right? So this, the 1 inch denting, it's really huge. Like we can feel it when we drive. It is, if you're familiar with faulting in a concrete pavement, a 3/4 inch faulting in a concrete pavement is a lot. So in the winter, when we drive on the asphalt pavement that has tenting, it's pretty much driving on a concrete pavement. The feeling is like you are driving on a concrete pavement that has also faulting. So in winter, you you do not get smooth ride on the asphalt pavement because of the tenting, especially in this part of the country. So now this location, the pavement was really good except for the transverse crack. All right. And also it has kind of a little bit of slope terrain across. I mean, like on one side it's downhill, the other side the houses were a little bit of up the hill. So it's like water flow through the pavement in the transverse direction. Okay. So this is something. So water can flow more, but if all the water do not go away, if the aggregate gradation of the base layer is not good, then it can result in tenting. And this is a really a good example of such case. We also went in summer. So just this picture is showing that on the one side there is downhill. So average of all the 6 different sites we are comparing here. So the blue bars are tenting measured in the winter, okay, and the orange color bars are measured in the summer. So you can see out of the 6 projects, 3 projects shown some amount of tenting even in the summer, and the other 3 shown cupping. What Matt was mentioning, cupping is basically the depression in the same location where tenting was in the winter. So you can see like basically here the pavement lose fines. Okay, it lose some materials, and then it just form like little drain or channel. All right, and one of the crack was really big, very deteriorated. Not one of the crack, one project has a lot of deteriorated crack. And then we tried to find out if there is any correlation between this value that we measure tenting versus base thickness or surface thickness. And as you can see, for those 6 sites, we took reading at multiple cracks in each side. So basically no relation. I mean, like we could not establish the base thickness and surface thickness. It didn't have any correlation. With the traffic, with the additive, we found out a little bit of correlation. I mean, more traffic showing more tenting. Okay, it's probably more tenting means, the more fines can go into the crack, or with the wheel repetitions, more water or the slurry mixed with the de-icing salt probably can go into, and that creates a little more tenting only. So this is what we have seen. So as I mentioned, we also reviewed a previous MINDOT studies result, where my friend Ayub and Eddie Johnson, they have created a kind of article, also published in TRV. So they measured some tenting, in few roads, that's highways under MINDOT District 1. And then I just briefly looked at like what is the magnitude of the winter tenting they got. So I just presented two sections result, and you can see like 7mm, 9mm. So which we also got, but in Wallace Avenue I shown you like we got 20 also, but this 6, 7, 8, 9, those were kind of the average that we have seen. All right. So, and our colleague, MINDOT colleague, Amy Thorson, who was in District 1, she provided some list of the road section which shown or which experienced tenting. Okay, so you can look at that comment on tenting. So these are our colleagues' comment. Okay, so why I have this slide in here, you can see like, the traffic in these roads. One road has 25,000 ADT, and if I believe that below, and then some has very less. Okay, so and also look at the structure here. So base layer thickness is 10 inch, okay, from 5.5 inch. So it's a good wide range, where surface layer is like 5 inch to 10 inch. So it's like, you really cannot say, okay, if your pavement surface is very thick, then there is no tenting. But within those data set, we didn't see like, so tenting can happen in pavement, irrespective of their thickness. Okay, irrespective of it's just, so what is important is the base material, if it is vulnerable to keep some water in it, and it cannot drain away before it freezes, that will create the heaving, right? If it is thick or not thick, I mean, like, this doesn't matter too much in tinting initiations. All right. So after understanding like the tenting, how much we can see, so and we saw like, let's say 5 to 20mm or 15mm tenting we get. It's very severe, so it's a concern for us, as Matt was also mentioning. So this tenting is a concern for driving during the winter. And the learning is that it can happen for low traffic to high traffic road, less thinner to thicker surface, or the base too. The next is effectiveness of pavement treatment. Now, as I told you in the beginning, this tenting topic is researched less, so we really do not have a specific database where the tenting is specifically addressed. So what we did in here, with the help of our MINDOT colleague, Amy and Steve, so we got this data from their HPMA, the Highway Pavement Management Application. So we got some data, and I'll tell you what data we got for 8 MINDOT districts. All right. So the data what we have collected is what is the IRI, what is the International Roughness Index, and I told you that IRI is a measure for the road roughness. More IRI means more roughness. right? Now what we did is this database has plenty of data. So what we found out first, we trimmed the data which only reported the transverse crack is the main distress. So transverse crack main distress, and transverse crack will impact IRI when they are tented or if they're pothole. So we sorted all the data and we just have pavements with transverse crack as their primary distress. And then what we did is we found out the IRI before and after the treatment. Let's say for this example, they use reclaim and overlay. Let's say overlay. Okay. So here, before they applied, it was 253. So very bad conditions. 253 inch per mile. Now, when they applied the treatment, it significantly went down. All right. So this is just an example. Some examples were like the IRI remained same. All right. So what we try to find out that effectiveness of the treatment with respect to the road roughness, and we saw from the MinDOT's TRB report that IRI and tenting has a good relation. So we are assuming that if a road has significant IRI, and that means the road was rough, and we are saying that so that roughness came from tenting partially. All right. So we had 8 main dot district road, 8,000 over 8,000 data, and 3 pavement types and 6 maintenance or treatment types. So among 3 pavement types, we have VFV, BOV, BOC. This is bituminous over aggregate base, bituminous over bituminous, bituminous over concrete. And then we had 6 different treatment. 4 of them are localized: crack filling, crack repair, crack seal patching, and chip seal and micro surfacing. All right. So and then we looked at the improvement in the IRI, or the, let's say, how smooth the road became after the implementation of the certain treatment. Let's say, for example, crack fill. So when crack fill was applied, let's look at the right side plot, which is rain cloud plot. Here you can see all the data. So for the 3 pavement type, let's say for the BAB, this group of here. So huge distribution, so there is variation. So overall looks like there is a little bit of positive contribution. So if you took the mean of this, like 2.08% improvement was there. All right. So that means IRI decreased after crack fill treatment by 2.08 in average. In all the projects which had crack fill treatment in this 8,000 database. Okay, so we did the same for other treatments, and I will not go in all of them. I will not read all of them. So this was for the crack repair. So for BOC, looks like the bituminous over concrete crack repair was very helpful. When you say crack repair, it's a little bit of extensive work, like cleaning the crack, drying, that making the router, then applying the sealing. I think, or if there is a little bit of other small work, so that is also done under the crack repair. So I checked the unit cost of crack repair versus, let's say, crack seal. It's almost twice. So crack repair is a little bit of extensive, and in this MinDOT database, they're separate items. So crack seal, crack fill, crack repair, those are. So for micro surfacing, you can see all positive, and they're very good. Like also in the rain cloud plot, you can see micro surfacing was a good surface treatment MinDOT have used, which could significantly improve the road roughness following the implementation. Whereas chip seal, I mean, like, I'm not saying chip seal is bad, but this database said the IRI was not improved. Probably the one reason is the preventive treatment. It is already applied on a good right surface, so the improvement was not that visible. That tells that maybe the chip seal is applied on the roads which didn't have more tenting. That's, I can tell it other way. Now, we already saw from our field investigation that the base layer thickness, surface layer thickness, ADT didn't influence too much. Now, in this 8,000 database, we wanted to understand what are the significant variables. And then for that, recently we did some machine learning predictor models. So here, this is just example of three different models, kind of very high level results, basically to show that the treatment type and pavement type, these are the two most significant variables. Means like the improvement in the IRI will depend on what pavement treatment you are applying. So all pavement treatment will not provide similar IRI improvement. For example, microsurfacing will give a lot, chip seal will not. So we and also see a little bit of it depends on the pavement type. So for the BOC, if we use crack repair, then it was more benefiting than doing other thing. So and it has been we didn't have to do all three, but our student was a little bit of curious to check, and then one model is a little bit of advanced than the other one. So he did all of them, and they found out all the models shows the same, that these two are the more significant variable. The next step was to rank those treatments. Okay, now for doing that, we did little bit of more statistical analysis. Again, we did two-way ANOVA test, if you are familiar with that. And again, this one, I will not read all those things, but this one also gave us the hypothesis that the treatment name, treatment type or name, pavement type, those are significant variables. And we did a little bit of more work to rank them. There is something called Bonferroni post hoc statistical test, which can be used to create a ranking. So we calculate some composite score, and based on this composite score, you can give a ranking. For example, for BAV, microsurfacing was giving the highest composite score. That means that performed the best. So we put ranking number 1. Second is patching. Again, these all are the data which are available in that Mindo database. Okay. So we understood, like, from available treatment which have been helpful in reducing the roughness, or let's say indirectly those tenting, which affects the road roughness. So, and after that, now this treatment you can apply on existing pavement to fix the issue, but we wanted to attack the genesis of the issue, means like the base materials, which is a big contributor of the denting. If the base material doesn't drain away water, or it can have its kind of structure is such that it can store more water, okay, or less water. So this thing can affect the frost heave of the base layer. So we did investigation on that. In order to do that, we have collected samples from 2 different plants here from Minnesota, Duluth, Oscar and Northland Pit. All right. So, and then my student just gave them the name. I know O for Oscar, I don't know why he said S. I didn't want to disappoint him, so I kept them. This N is North. Okay, so we collected like in 2 times, so he just added a new, another N is for new. I know that much. So, and we also collected some base material sample from some potholes in kind of around on Duluth to study the salinity level, because we use de-icing salt that goes into the base material, and if it increases the salt, so we also collected some materials directly from the potholes. We took permission from the city of Duluth for that. Okay, and then also we collected some, de-icing materials like brines and what is being used by District 1 Minder. So we collected those. We did different tests. I'll jump into the results, but the most important test we developed is, starting the frost heave, and then these tests we developed from the scratch. Everything is our thought, and we developed a method which can measure the frost heaving in the lab environment. So this is the gradation of the four soil samples, the original gradation. We also did some changing in the gradation and later on, but these are the gradations we got. Okay. So out of these four, the Oscar samples, SO and SON, they have like around 15% finds. And we collected these samples in 2 different years. So probably the same source. And you can see the next year one, you did the sieve analysis, we got almost the same. So for these one also, we got the same, even though gradation was different. All right. So so this SN aggregate was pretty close to the maximum density line at the lower or the fine side of the gradation. The SO, which is far away from the maximum density line. So maximum density line is this theoretical line. If the gradation is more close to this line, means the soil or the aggregate base layer will be more dense. Okay, so this SO line here, this or SON line here, it says that it will be having pores. It will not be having more dense. All right. So in this study, actually, we proposed a factor called a CB by FB index, which is coarse void area by fine void area. How we found this one out? We basically use the gradation curve. Okay, so maximum theoretical density line and the gradation. So we divided this entire area into two parts. The area below 4, the sieve number 4 is fine void and the other one is coarse void. Okay, so coarse void by fine void is the CB by FB index. Now if it is greater than 1, means the coarse void is more, big size pores are more, and this is fine, more means fine void area, fine pores are more. All right. Now, when we analyzed the gradation of each, and we calculated the corresponding the void, fine void, and then coarse void, and then the total void, and then we found out the ratio of this CB by FB. Here, I'll jump into this one. You can see that SN had the highest. All right. I don't want you to remember that, but we'll come back to this in the next few after some time. So SN had the highest CB by FB. It means if we compact this, it may leave a big, the aggregate structure is like that. It will have some big size of pores, holes in the structure, and the small pores will be very less. From the salt, from the samples that we collected from the potholes, we found out the salt content, but the salt content we found out for 4 different samples. But we also reviewed Johnson study, A.D. Johnson study, and then the amount they had was way more than that we got. So we basically stick to what they have they measured, because we wanted to see the worst scenario. So frost heap test, we did 2 different types of test. In one test, we really tried to mimic the field situation. All right. So here, the let's say the base layer is cold up and not cold, or a little bit of warm at the bottom. Okay. So we tried to create that gradient, and in another one, we just made the entire base layer frozen. So for doing this variable temperature thing, we had to do a lot of arrangement here. So this is like temperature chamber, and then at the bottom 1/3 we provided some heat. We had water in here and the heat, and this entire thing was in an environmental chamber. And we got minus 11 degrees Celsius at the cold region for that. But in the other one, we got minus 40 degrees Celsius temperature, pretty close to minus 40 degree Fahrenheit. So these one, we just kept the chamber really cold and uniform. So these are some picture of the test, sample preparation and all, and also we had thermocouples to measure the temperature. So these are some more picture. All right. So so we wanted to test our system first. So here we used SO blend, means like from Oscar pit, we got these samples. So what we did, like 2 samples, we tested multiple replica, like 3 results, 3 samples minimum for each. So the original sample had almost 15% fine, and my student actually did some modifications to drop the fine to 3%, and he tested. So here, more fines, more tenting or more heaving, less fine, less heaving, this one shows. But with salt, we thought it will be more tenting, because we thought the salt will absorb some more water, but it did not happen. And on this one, on ascent blend also, we did without salt and with salt, and the trend the same. So with salt we were getting less tenting. Now the literature say if you have more de-icing salt, you should see more heaving or tenting. That's correct. If the salt really absorbs a lot of water, then you will see, because water accumulation more, ice accumulation will be more. But in our test platform, we found out that that doesn't happen within our test. I'm not saying like in the field, but here what we in order to prove that, what we did, we just kept some samples here, and each one had the highest amount of the salt, and then we had some water in here to see if this base material absorb water. It did absorb, but those were negligible. It's like 0.03, 0.02%. Okay, so we then, after that, we thought, okay, maybe, if we are just studying the base materials gradation or the base materials aggregate structure, then we probably are not adding the salt. And also we tested these at minus 40 degrees Celsius. So at that time, the effect of salt is not there. So, and we did the measurement. And again, if you remember this, the fine, I have this table in here. Let's look at that SN. SN had 9.9% fine aggregates. So 9.9% fines, and min dot limit is 10%. So with the 10% fines range, it is good, but it has resulted the highest heaving. All right. Now this one is lowest fine. All right. So this one is lowest fine, and this is highest fine. So we thought this SO, which had the highest fine, should have resulted the or S1, these two should have resulted the maximum frosting, but it did not. So these tell us that fines can affect, but the overall structure actually is more important. We also did permeability test. I'm not going into more details. So let's look at the correlation that we saw. So the frosty versus fines, when we plotted, we really didn't get a good correlation, okay, here. But when we did frosty versus the CV by FP index, look at that, we get a really good correlation. So instead of fines, we probably should be looking at these one, determine these, and then that can tell us better that if this base material is susceptible to frosting or will result tenting or not. This CB by FB index also has a good correlation with the permeability test results, right? And the frost heap and permeability also have good correlations. Of course, more permeability means more space for water. It will also create more frosting, but that's kind of the tricky here. So, but more permeable means better drainage. So if you have slow good permeability, the water may go away. But if you have high permeable base, but the pavement doesn't drain away the water, then it's a problem. Then it will create more tenting. So, and the next we went to the field. Out of those many locations, we went to 3 different locations, including the Wallace Avenue, where we saw a lot of tenting. We collected some base materials. Okay, thanks to Miranda from St. Louis County, and then other colleague from St. Louis County who helped us. Now we analyzed those, and then we found out the fine content is 10% or below, so within the MnDOT boundary. All right. Now here we did the analysis of the void. Okay, so let me go in here. This is most interesting thing. So in that 3 location, we had the average tenting measurement. So in Wallace Avenue, we had 14.08 the average. Now in the frost heap test, the frost heap value was also the highest among the 3, and it just, you can see it is clearly following more tenting, more frost heap, medium tenting, medium values of frost heap. This is a very good trend that we have seen, but the limitation is only 3 data, so our confidence is not that much in here. And with the 3 data, and I tried to relate again, this is a premature correlation because only based on 3 data. So this is one of the limitations of this study. Right, I could see an exponential relation. So field measure tenting with lab measure tenting, lab measure frost tip. So they have a good relation. So so the frost tip test setup that we developed at UMD, I want to say that really can capture the frost tip potential of the field. And these results gave us really good indications, but we just need additional data. Now, we wanted to correlate the lab measured frost tip or the CB by FB values with the road conditions if we want to implement that. Now, I took help from Ayub's study again, Ayub's and Johnson study. So they did a great job. They correlated the pavement condition, road conditions with the tenting. So 2.5 less than, they said good, 2.5 to 4.4, they said moderate, and then greater than 4 is, I'm sorry, it will be 4.4. I thought I corrected it. So that's 4. Now, using the correlation that we developed in this study, we found out, means if you want to have a good road with less or no tenting, let's say less tenting, so the frost tip, lab measure frost tip should be less than 0.72, or CB by FB should be less than 0.88. Now, corresponding to these values, we calculated the lab measure frost tip and CB by FB for other. So now, what do you want when we construct the pavement? We probably want to achieve this one, 0.88, right? So 0.88, if we can achieve in the base material, that will be the great thing. Now, coincidentally, we are not alone in this, so this similar approach is already applied. Now, if we look at MnDOT's concrete for pavement and the recommendations for the air content, entrained air content is 5 to 8%. So what is entrained air content? The finer air bubbles. So these finer air bubbles, we want 5 to 8.5%. Why we want those finer air bubbles? Actually can provide some space to ice. When the water become ice, it needs extra volume. So these finer voids can provide that. So that's why we need air entrained concrete. Look at brick masonry. All right. So brick masonry, there is also different grades, but they have a coefficient called saturation coefficient, and the target is 0.8 to 0.9. All right. So for 0.8 means it should be less than 0.8, and this saturation coefficient is pretty close to our CB by FB index. Why? Because the saturation coefficient is the ratio of absorption by 24 hours submersion in cold water. So this if we do the water absorption using the cold water for 24 hours, that actually fills the pores voids, the big size voids. And in order to get the absorption by the fine voids, you have to boil the brick, right? So that means this ratio is you can say coarse void by fine void ratio and their value is according to ASTM, I think 62, C62, so 0.8 to 99. So these systems are available, but they were established through many research projects. All right. So the method that we followed, it's not arbitrary. There are other materials in civil engineering who actually have the similar kind of approach. All right. Now, even though the data size is limited, so we came up with some really not cool, but a very draft level of decision tree. And as I said, this is an ongoing work. We just submitted the report. The TAP didn't review it yet, but this is what I proposed. Again, this will be kind of changed based on the opinion. So if you really do not separate between surface treatment or localized treatment, we see like for BAB, if there is tenting, microsurfacing is really great. Okay, but now if you want to do for localized treatment, patching should be good. Microsurfacing again stood out for the BOV. BOC, which is bituminous over concrete, right? We have so many roads in here. So for that, crack repair, like extensive repair of the crack was found out good. Now, if you want to say, okay, I want to divide the surface treatment and localized treatment. Now for pavement type BAV, microsurfacing was very helpful. Microsurfacing for surface treatment is true for all three types of pavement. So microsurfacing really did a great job. I mean, like great job in those database. But for localized treatment, it's somewhere patching or crack repair. So again, this is another proposal we have. We do not have a lot of variables here, so it is not very big decision tree. It can even be made a little bit of more simpler if we do not include the second choice. But or we do not have a lot of options, but maybe we do not need even decision tree. But anyway, so that this decision tree is now that was for fixing existing pavement, right? So this is for existing pavement which has tenting issues. But now if you want to limit frost heave on the base of the base material itself, then as you said, I recommended that CB by FB index should be less than 0.88, and also fine content what MinDOT already imposed, the 10% that too probably will give. Now you can say, why do you have these things? But yeah, I mean, like if it's not a super important road, or it's not a highway, but it's you can allow up to 4.3 millimeter of tenting, then you could relax a little bit on that value up to 1.42, but fine content, so 10% would be the criteria. So this is another decision tree we are proposing. So again, this is under the review. All right, so in the conclusion, I'm not sure how good I'm on the time, sorry. So the tenting we saw is a concern, right? And which increases the road roughness. IRI and tenting, we found there is a good relation between these two. So while 2.5 is kind of the value they mentioned that affects the ride quality, but our Minnesota roads can have 15 millimeters of tenting, so which is the reason our driving in winter is not smooth. Okay, so so when we saw the tenting severity, like from the data that we had, was really not function of the base or asphalt thickness, but traffic could increase that. And we saw tenting can stay in summer as well, because the fines that if extra fines goes into that stays there, or also can result in cupping. When this thing happen, maybe the crack is already deteriorating, you are losing materials of the asphalt material is also getting lost, the crack will be wider. uh, Effectiveness of the treatment we saw for surface treatment, micro surfacing is way better than the chip seal data side. The effectiveness of the localized treatment we saw, uh, crack repair was good for BOC because it is like overlay on concrete, and for other two, patching was showing again in the database a good result. And I'll not read all of them, but for CB by FBLU, you saw that that's really very useful. That's the parameter. In addition to the fine content, we should be looking at that. That can give us a very good engineering standard. All right. So if we control that one, we may see some less tenting in the in the road. All right. But again, this is established based on a very small size data. So which I mentioned in the limitation. So I'm not going to read all of these things, but in simple, I'm just saying that the database that we used is a little bit small, especially for the CB by FB index versus frost tip and field tenting. Is this relationship that we established, it was database is very small. To implement such a new parameter in practice, additional research and further laboratory testing and field testing is recommended. But this project, nevertheless developed a good procedure, and I will say it's a big first step. But if we really want to implement right now, we have to be a little bit of cautious. I think keeping aside research work would be the great approach to go forward. Thank you very much.
Thank you, Manik. You did great on time. So we do have some time here for questions. So encourage you to raise your hand and we can unmute you. Otherwise, you can put any questions you have in the Q&A. I actually have a couple questions for you, Manik, both related to the actual pavement sections that you measured the tenting on. Were you able to find out from, perhaps the construction notes or plans and specs whether the aggregate base in any of those roadways contained recycled material?
Oh, yeah. Thank you very much. No, we did not have that data. That's a
Okay.
very good point. Okay, thank you.
And then just another question about, did you record or did you think at all about whether these segments that you measured were in the sun or the shade?
Okay, so there's the day when we measured, we didn't specifically. I see where are you coming from. We didn't specifically saw that, but to the best of my memory, the location didn't have too many of trees. I mean, it is kind of not covered by big trees, or that's my memory from there. Yeah,
Which is good, right?
of
Better
course,
for
I think.
acing maybe. So we have a few questions. Thank you for answering those. We have a question from Jacob. Was there any correlation between the type of aggregate material, limestone, crushed gravel, river rock, recycled concrete, etc.?
Yeah. Thank you very much for this question. I mean, I'm glad that you asked, Jacob. But the scope of the study, we could not include all those variables. We really cannot pinpoint on those. We focused more on the gradation, and we didn't have. I mean, like, we spent a significant amount of the time in developing the frost tip testing and in other works. So that's what I'm saying. Like, the database, the test does not include so much of variables in it right now.
Another question, this time from Matthew. It sounds like microsurfacing is a more effective treatment for tenting, but is it significantly more expensive?
Yeah, it's a little bit of expensive. Yes, I was just checking that unit cost. It is a little bit costlier than the chip seal.
Okay. Does anyone else have a question for Monik or Matthew or Chad? So it doesn't look like we have any more questions. So thank you very much for our speakers. We're going to go into a round robin part of our webinar today. And we have just a few questions to ask since we have time for them. The question we're going to start with is, what current infrastructure issues are you or your organization facing? We still have 30 some people on the call, so I know people have thoughts. If you're brave enough to bring them up and start a discussion, that would be great. I'm guessing maybe getting construction done before the weather, that could be maybe an issue. I'll take any feedback on that one, but I will pose the next two questions as well in case there are thoughts on those. Do you have any organizational, informational, or event updates to share? And the last question we have is, what ideas do you have for potential future council meeting topics or speakers for webinars? Well, I'll just plug one more time that CTS will be hosting the research conference next week. So that's Thursday, November 6th, and you can still sign up if you are so inclined.
Thank you very much. I think that's probably end of the session today.
Yes, thank you.
Thanks. Yeah, thanks for the opportunity. And I would like to thank Matt and Chad for their help. I know I could not submit tasks in time, but they were so supportive and accommodative. Thanks a lot to them too.
Well, thank you, Monik, and thank you both, Chad and Matthew. Thank you, everyone, also for attending today, and have a great rest of your day.